Hello, today we will be discussing three methods to solve a quadratic equation. Now, depending upon various cases, a particular method may be preferred over the other. So, let's get into the methods. The first method, as some of you might be familiar already, is splitting the middle term. So, let's take a quadratic equation. As you would remember, a quadratic equation is basically a polynomial equation whose degree is 2, which means the leading term has a degree of 2 and the coefficient of leading term cannot be 0. All the other terms are actually optional. If we take this as a quadratic equation, 2x squared minus 9x plus 7, we see that the coefficient of x squared is 2, that of x is minus 9, and that of the constant term is basically 7. So the idea is to write this middle term, that is the 9x. You can focus over here. This middle term has to be broken down into two terms so that the sum of the two terms equals minus 9, which is basically the coefficient of x, and the product of the two terms equals the constant term times the coefficient of x squared, which in this particular case would be 7 times 2, which is 14. Now, by a quick guess, you can see that since you want two numbers whose product is positive, either they are both positive or both negative. But since the sum is negative, so both of them have to be negative. And by trial and error, or if you want to be more rigorous, by trying various cases of prime factorization, you can find out that the numbers are minus 2x and minus 7x. So we can write minus 9x as minus 2x minus 7x. Then taking the HCF of these two terms, 2x, we will be having x minus 1 common. And when we take the common term from these two terms, we will again have an x minus 1 as a factor. So you can see it leads to both of them become green, which means x minus 1 is a common factor for the first two terms as well as for the second two terms. So now between these two terms, we can take x minus 1 as a common factor and combine the part that was the other factor of each of the individual terms. So basically, from two terms in subtraction, we get two terms in multiplication. When we have expressed our polynomial equation as a product of linear or quadratic factors or any other factors in general, we can see that we have factorized the equation. So over here we have completely broken down the quadratic equation in terms of two linear factors, and if the product of two numbers is 0, at least one of them has to be 0. If 2x minus 7 equals 0, it will give you x equals 7 by 2, that is 3.5. Or if x minus 1 is 0, then you will get x is equal to 1. As a proof, you can just basically put back the value of 1 in this equation and simply check. So you will get 2 minus 9 plus 7 equals 0, and you will get a similar value even for x equals 3.5. I believe many of you might be familiar with this already. Now let's go to the next method, which is, in my opinion, the most direct method. It's called the quadratic formula. And over here, you do not have any restriction. For example, in when you're talking about splitting the middle term over here in this particular method, sometimes the numbers may be out of your comfort zone, and it would be very difficult to actually guess that. Not to mention, sometimes such real numbers may not even be possible. So quadratic formula just gives you a direct answer to every case. It works for all the cases. And you can see that if ax squared plus bx plus c equals 0, then you will have x given by minus b plus minus under root b squared minus 4ac by 2a. This quantity b squared minus 4ac is also called the discriminant. This is a standard formula. You'll find it in any textbook. And now let's take an example. So if we have x squared plus 13x plus 42 equals 0, clearly over here a is equal to 1, b equals 13, c equals 42. And if you plug back the values of a, b and c in this particular formula, you will get the value of x as minus 6 comma minus 7. The root for two different the basically the source for two different roots is this plus minus term. All right, so basically if you just wanted repeated roots, which means if your polynomial equation was a perfect square, then this discriminant should be 0, so that plus 0 and minus 0 do not really make a difference. Method 3 is completing the square. So let's take an example and actually illustrate this. You should be knowing this identity in prior to understanding this method. So you have a plus b whole square equals a square plus 2ab plus b square, and if you replace b with a minus b, you will get a minus in front of 2ab term. So I've combined the two identities in one over here. Let's apply this identity to solving this particular quadratic equation. Let's take x square minus 6x plus 8 equals 0. So visualize this as the a square term. Visualize this as the negative 2ab term. Since it is negative 2ab, we already know 2 is a constant and the a can be taken as x. The b will therefore become 3. You can see that minus 2 into 3 into x, this is not 2.3, this is 2 into 3 into x. That gives you minus 6x. So if this is a square and this is minus 2ab, you need a b squared now, which is b over here is 3, therefore 3 square. And since you cannot just arbitrarily add any number, it makes sense to even subtract it. So you will get 3 square minus 3 square plus 8 equals 0. Now, the first three terms basically are just x minus 3 whole square. And if you quickly evaluate the sum of these two terms, this is minus 9 plus 8, that gives you minus 1. Bringing 1 to the other side, you will get x minus 3 whole square equals 1. So on the left hand side now you have a perfect square. On the right hand side also you have a number which is a positive number. So if x minus 3 whole square is 1, it clearly means that either x minus 3 equals 1 because 1 square is 1, or minus 1 because minus 1 square is also 1. So this I believe is kind of more reasoning based. You can say x minus 3 equals 1 or x minus 3 equals minus 1. The first equation will give you x equals 4 and the second will give you x equals 2. And you would get the exact same answers for any if you do any of the methods that I have actually described over here. So that's it, I think, from this video. If you had any doubts in what was discussed or would like to know more, please make a comment and I shall see you next. Thank you.